This video illustrates the effect of battery AC compressor power consumption on a regular and plug-in hybrid vehicle and the various parameters calculated by the PowertrainLive vehicle model. Vehicle air conditioning loads are one of the most significant auxiliary loads present in the vehicle. An AC compressor can add up to 6 kilowatts of peak power load and about 2 kilowatts of steady-state load on the engine or the battery. The fuel economy of the vehicle drops noticeably when the AC compressor is on, and this effect is even larger in high fuel economy vehicles. We will look at two different scenarios in this video. The first scenario is the impact of AC compressor on a conventional powertrain. We will do this by calculating the reduction in fuel economy and the increase in grams of CO2 per mile from the compressor load. The second scenario will be the battery range reduction on a plug-in hybrid vehicle from the compressor load. First, let's look at the conventional vehicle. This is a typical pickup truck vehicle model with 6-speed transmission. The vehicle model is set up to run the highway FET drive cycle. The baseline vehicle highway FET summary results are shown here. You can see the cycle average fuel economy and the CO2 emitted for the drive cycle, and the detailed subsystem results for each of the subsystems. In PowertrainLive, we turn on the AC by adding the compressor load as a mechanical accessory load in the engine subsystem. The compressor load is entered as a time-dependent load. With the AC on, let's rerun the highway FET drive cycle analysis. Here are the summary results of the new analysis, and you can see the fuel economy change and the increase in grams of CO2 per mile with the AC on. As you develop smarter technologies and controls for the HVAC system, you will be able to quantify that change in power consumption into fuel economy improvement and reduction in grams of CO2 per mile. You can do this both on cycle and off cycle. Now let's look at the AC compressor load impact on a plug-in hybrid vehicle. Shown here are the performance characteristics of a popular plug-in hybrid vehicle. Let's run the full vehicle model for the UDDS drive cycle, with and without AC compressor load, to see what the typical results look like. Just as in the conventional vehicle, you will be able to see summary results of the fuel economy and CO2 emitted. But for a plug-in, there are two differences. Firstly, instead of the MPG, the MPGE, miles per gallon equivalent, is calculated. Secondly, the battery power consumption results are also reported over the full drive cycle. Within each subsystem, you will be able to see detailed calculated parameters such as battery current draw, heat rejection, state of charge, terminal voltage, motor torque, motor speeds, and motor heat rejection. The battery heat rejection is very commonly used as an input into the battery thermal model for co-simulation with the PowertrainLive vehicle model. A similar comparative analysis can be performed with the AC load imposed to understand the impact on all of the operational parameters. You can perform studies with this vehicle model to understand the full vehicle impact of component performance change or AC and heater load change due to smarter thermal management strategies. For more technical support videos, please look in the technical help section of PowertrainLive.com.